In this video I covered shipboard ventilation systems. I go over obviously a fan and then how reheaters and cooling coils relate to the ventilation system. Before we continue, remember, if you find the material in this video too technical, please watch earlier videos where I cover basic electrical knowledge. Keep in mind that the first 28 videos are best understood if you follow their sequential order. Now, back to our video. So I'm going to talk about ventilation systems, and for ventilation systems, well, first thing is we got multiple spaces. As a matter of fact, we got spaces in here on this deck, and then second deck and third deck. And there is this fan that when it turns on, it just blows air through this ducting. So as air flows, it just puts air into all these spaces. Now this is the duct, so where the air actually comes out. Now, let's say that it is a hot day. What's supposed to happen is that there is a solenoid valve that opens and it will allow chill water to go into this heat exchanger, and it will cool the air that passes by. Now, once the air continues, it will cool down the space down below. Now, what if it's winter and if it's cold? We want the solenoid valve to stop, well, the water flow or chill water, and then they got these heaters that they will come in, and inside there it will just heat up the air, so as it comes out, the air comes out warmer. They got these controller heaters. Controllers, or heater controllers should I say, they energize the heaters. So they got this controller or heater controller that energizes this heater, and this controller heater energizes this particular heater. There is also a fan controller that the fan controller, or the fan gets controlled by his own fan. Now, there are multiple sources of power. So there will be one 440 system that will give power to the fan controller, and that is also going to energize the fan itself. But the fan controller is going to have a step-down transformer that is going to provide 110 volts control power. That 110 volts will give power to all of the heater controllers. And that also will be given power to energize the solenoid valve. What I'm trying to represent here is that the red power lines, they come from the fan controller. And that is 110 volts for the controller side, for the reheater controller. If we lose power over here, that our fan controller doesn't get power, we lose control power in all of this. We will not have cooling, neither we will have heating. However, each local heater does have its own 440 going into it, because, well, heaters themselves, they consume a lot of power. So even though 440 is applying to them, the 440 is for the actual heater, but the control side power comes from the fan controller. Now let me talk about just one particular fan controller and one heater controller along with its associated heater. So I hope not to be too confusing over here, but the boxes, this box over here represents a motor controller. This one over here represents a heater controller, and this one over here represents the overhead heater. As a matter of fact, these are the heaters. If you see, they are connected in a way that the first one gets power from the green wire, first and the second one. The second one, it gets power from the blue will be barrel phase, and the third one is, and so on and so forth, so they are balanced. Now, there are two different power sources. There are two different breakers per se. So this breaker, let's say this is breaker alpha, gives power to the fan. This is breaker bravo, gives power to our heater. Now, whenever somebody presses the on switch for the fan, as you already know, the coil for the contactor closes or energizes, and it closes, right, these contacts, and power will flow into the fan and the fan will spin. Now, at the same time, there is over here, there is these power lines, which they are protected by fuses, and they energize this 110 volt circuit. The 110 volt circuit, which now is the orange line, at least for the reheater side. Look, one side, let's call this one alpha phase, it goes straight into a coil of the contactor for these contactors over here. The other side is going to be conditional power. So for the reheaters to be on, these are the permissives. Power will have to go through this one over here, going into the thermostat. This is the symbol for the thermostat. I just didn't do it over here. As soon as this switch is closed, power will go in and now come over here. But then look at this. The heater, the overhead reheater, it has a built-in high temperature thermostat. If in case it gets too hot over here, this will open. But if assuming that this is not too hot, because air is flowing through it, and now assuming that there is not a overtemp condition over here, this switch will be closed and power will continue and you get to here. And as you have this on and off switch closed, boom, you put power into this coil, and that means that this contact's closed and therefore the heaters come on. If all of a sudden, for some reason, the fan it just gets stuck and there is no air flow, that means that, well, there won't be air going through the heaters to remove the heat from the heaters. If the heaters overheat too much, the high temperature switch is going to open, cause power, remove power from this contact coil, and it will open this, de-energizing the heaters. If the space gets too hot, the temperature thermostat will open, also killing power to every heater. If the space gets cold, now notice that over here also there is power always to the solenoid, and there is power, there is another leg of power, which I drew it wrong in here, I cannot correct myself right there. Now from the other one it comes in and it goes and it feeds this side over here. If this switch, bottom switch closes, now pretty much this potential, which I said that it was alpha, it will be put over here, and I say that this side over here was bravo, it would be over here. So now we got the two potentials, and the solenoid will close, and it will allow chilled water to go through it and go into the cooling exchanger to cool down the air. Alright, so I know I already talked about this, but I just want to make sure that it's very clear that the transformer is located at the fan controller, and it gives power, control power that is, to via the thermostatic switch, and the thermostatic switch controls both the reheater contactor coil and the solenoid valve. So in that way, he has the power to decide if it's time to cool or if it's time to heat up as needed. And this is a high temperature safety thermostat that is actually located inside of the reheater itself. Ventilation controllers, typically they have one step down transformer to 110. For single speed motors, you will have only one contactor and then the overload protection for that particular motor. There is two sets of fuses. Now that will be for control power on the heaters. If we lose power to this whole ventilation controller, the heater controllers will lose power, but they still be energized by 440. Some ventilation controllers have their own start and stop buttons. Ventilation controller does not have a push buttons. That means you gotta go to a Christmas tree controller to turn the fan on. Here we got a Christmas tree controller. From over here we can start and stop multiple fans. The new thermostatic switches, they give you more information than the ones before. And they actually have a network cable that it lets a monitoring system know what the current temperature of the space is. Inside you find three cables because, well, that one, this is powered on. This gets 110. This over here, we got our common, one to energize the cooling coil and one to energize the heater. And then that is our network cable. Here we got a ventilation heater. So ventilation heaters, they have two cables. One is the 440 coming in from the contactor to energize the actual heater that is inside there. The other cable is just a two-conductor cable that goes to the switch. By the way, that is the thermostatic switch, or over-temp switch, should I say. Whenever that switch trips, this is the reset for it. You gotta press it really hard to be able to reset it. Reheater controllers, they only have typically one contactor, which is to energize the actual heater, a little terminal board, and the on and off contacts for the switch. The control side coils, they receive the 110 volts, obviously when this switch is closed and when the other permissions are met. In the back, we got 440, which is, well, the L leads are on top, and then at the bottom is where the heater is at. The contactor bottom connections that go to the heater, they are a great place to check resistance of the heater. Light fan, and the exhaust of the space is working, so therefore it's drawing air to the point that this fan is free spin. So whenever I try to do a resistance check, I won't be able to read if this motor is good or bad. I will have to actually physically stop it and put a brake on it, something to stop it, so that I can actually take a good set of readings on that.